Hello class, Mr. Sutton here, and today we're going to be talking about function composition and inverse functions. This is our first notes video. Make sure you have some paper and pencil to take notes on throughout the video. You want to record all the definitions and notation marks as well as the examples in this video so you can reference them while you are working on your practice and mastery assignments. So first we're going to talk about function composition. Function composition is applying one function to the results of another. That is your definition. This is our notation. So we're applying one function, this function f, to the results of another. So we're applying this function f to the results of function g of x. So in another way you will see this represented is like this, where the way you read this is f of g of x, just the same way you would read this, f of g of x, but a different notation here. So we have f and then a circle and then g in parentheses, and then outside of that we have an x also in parentheses. So these mean the exact same thing, and the order matters here. These two notations are different than if I had g of f of x. Right, so g of f of x equals g of f of x. These are the same, but these two function compositions are distinct because the order matters. So f of g of x is not the same as g of f of x. But the basic idea for these function compositions, let's say we're trying to find the function composition f of g of 3. Let's say we're trying to figure out what that equals. So you want to start on the inside. So let's say g of 3 equals 4. Let's just say that. I don't have a definition for the function g right now, but let's just say that g of 3 equals 4. Okay, so our input is 3, our output is 4. Now this output 4, it's the output for this function g, that becomes the input for the function f. Because g of 3 equals 4, now we can substitute in 4 for g of 3. So now I plug that in right there, and let's say f of 4 equals 7. So then 7 would be the final answer. Okay, and so the different ways we can represent this types of problem, the functions can be given to you graphically, or they can be given to you as equations. So there's different ways you can define the functions, but this is the basic idea. So here are some examples pulled from Delta Math where the functions are defined as graphs. So it says evaluate f of g of -5. So the first thing we want to do is figure out what is g of -5. We want to start on the inside. So g of -5, that means our input is -5. So that is our x value, -5. So we want to figure out where the function exists at x equals -5. So we go to x equals -5. The function exists down here at this point. That is the only point on our graph that is at x equals -5. So then the output, at that point, the y value is -6. So what that means is our new function becomes f of -6, because we now know that this g of -5 equals -6. So we plug that -6 into our f function. So now we have to figure out what f of -6 is. So now we look over here at f of x. Now this is where some people make mistakes, is they stay on the same graph. We have to look now at f of x, And now we're plugging in -6. So -6 is now our input. So we have to look on the x-axis. Where's -6? It's right here. Now we have to figure out where our graph exists on x equals -6, which would be up here, this point right here. And what is the output at this point? The output's on the y-axis, so that would be 6. So our answer here for this one is 6. So think of it like a map. It tells you to start at -5 and to use this function. So -5 then tells you to go to -6, and then we're using the other function, so you go to -6, and that tells you to go to 6. All right. So let's look at this other example over here. Here we have f of g of 3. So first we're plugging 3 in to function g. So we gotta figure out what that is. We plug in 3 on the x-axis takes us to this point right here. That's where our function exists on x equals 3. So our output there is 6. So g of 3 equals 6, which means we're plugging 6 into f of x now. Our output for this function becomes our input for the outer function. So now we want to plug in 6 into f of x. So where does our function exist on x equals 6? That is up here, right? And output of f of 6 is also 6. So that would be our answer for this one. Now we have some functions here defined as equations instead of as graphs. So same idea. We have f of g of 2, which we know that f of g of 2 is the same as f of g of 2 written this way, which you might want to rewrite it this way because this might give you a better idea of where to start. So remember, you want to start on the inside. So we want to figure out what g of 2 is first. So we plug in 2 into this expression here. And then you want to go ahead and simplify this on the right side. So I'm going to go ahead and do that now. So I got g of 2 equals 7. After I simplified all that, go ahead and pause that and look over that and make sure you get the same thing. And then from there, we now know that g of 2 equals 7. This right here equals 7. So we plug 7 into f of x and figure out the output there. So if we're plugging 7 into this function, we want to go ahead and plug 7 in for x. So now we have -5 times 7 minus 11. I'm going to go ahead and simplify this on the right side here to figure out what f of 7 is. So I got -46, -5 times 7 is -35, and then minus 11 is -46. So that means f of g of 2 is -46. All right. So I'm going to go ahead and do the next one here. Again, you might want to rewrite it from this form to this form. This might give you a better idea of where to start. So you want to start on the inside, so that is f of 9. So then we want to plug all that in to f of x. And then once you have all that plugged in, go ahead and solve, or simplify, excuse me, the right side. Solve for f of 9. So I got f of 9 equals -4, which means that is what you are plugging in for g of x. So f of 9, we now know that this all equals 4, so that's what we want to plug in here. So g of -4, sorry, I was saying 4, it is -4. So we want to plug that in here. So I'm going to go ahead and plug that in to the right side of this equation. So it should look like this. Now I'm going to go ahead and simplify this right side. So I got 54. -4 squared is 16, times 2 is 32, -6 times -4 is 24. So 32 plus 24 minus 2 is 54. So g of f of 9 is 54. So that's how you do that type. We have one more type where this is f of g of x, where we're not given an x value here to evaluate. So the difference of this type is we are just using x. We're leaving everything in terms of x. We are taking this g of x expression and plugging that whole thing in for x in this f of x function. Okay, so we're plugging g of x into f of x here. G of x is on the inside. So we want to take our f of x function, -2, and then where the x is, we want to plug in that g of x function. So I'm going to first write it like this, so you get the idea. And then next, I'm going to take all of this 3x squared plus 5x plus 14 and plug all of that in there. And so we have -2, and then inside these parentheses, I'm going to plug in all of this. So 3x squared plus 5x plus 14. And then outside, don't forget the other parts of f of x. So we got to make sure we include this plus 10 here. All right. So this whole function is f of g of x. So we have one more thing we can do. We can simplify this. It does ask for this as a polynomial in standard form. So we want to simplify this and put it in standard form. So I'm going to go ahead and do that now. So first thing I did was distribute the -2. So 3x squared times -2 is -6x squared. -2 times 5x is -10x. -2 times 14 is -28. And then you can combine like terms. The -28 plus 10 gives you -18. So f of g of x equals -6x squared minus 10x minus 18. And that is all we can do there because we don't have an x value to plug in now. So that's as simplified as we can get it. This is our polynomial in standard form. So now we're going to talk about inverse functions. Inverse functions are functions that reverse each other. So the notation for this, our normal notation is f of x equals y, where x is the input and y is the output. The inverse of this would be, we use this notation, f to -1. This looks like an exponent. It's not actually an exponent. That's just the notation we use. So you don't want to call this f to the -1. You would just call this inverse of f of y equals x. So now y becomes our input and x becomes our output. All right, so it just reverses the operations of the function. So the x and the y switch places. So if you think of it in terms of a mapping, right, our usual mapping, our f function goes this way. Our inverse function would go this way, right? It's just the reverse. So with that said, how do we find the inverse function? So here we're given a function. We want to find the inverse function. First thing we want to do is rewrite your equation, but instead of f of x, we want to write it as y equals x plus 4. And then the next thing we want to do is switch the x and the y. So this already, once we switch the x and the y, is our inverse function. But the thing is we have to get it into slope-intercept form. So that means we want to solve for y. So I'm going to go ahead and subtract 4 on both sides. So we get y equals x minus 4. And then the other thing we want to do is rewrite it using that inverse function notation I showed you. So the inverse of f of x equals x minus 4, like that. So this is our inverse function of this function. And you'll notice that the operations will always be opposite. Which for ones like this that are simple, you might be able to intuitively come up with the inverse function. But once you get more into more complex functions, you want to make sure that you are able to do this process because it becomes a little less intuitive. So I would always recommend going through these steps. So I'm going to go ahead and do this one over here. Plug in y for f of x. And then switch the x's and the y's. And then this is our inverse function equation. So now we want to go ahead and solve for y. I'm going to go ahead and do that now. So first thing, subtract 4 on both sides. You get x minus 4 equals 4/3 y. And then multiply both sides by 3/4 to get rid of this 4/3 on this side to get y by itself. Remember, we want to get y by itself, so we got to get rid of this 4/3. So multiply by 3/4. So that becomes just y on the right side. On the left side, 3/4 times x is 3/4 x. 3/4 times -4 is -3. So you get y equals 3/4 x minus 3. And then again, the last thing you want to do is rewrite it using that inverse function notation. So like this. All right, so this is our inverse function. So again, already it's looking a little less intuitive as to what the inverse is. So that's why you need to make sure you repeat this process and don't just try to guess as to what the inverse is based off of the operations you're given. So here we have some other more complex examples. So I'm going to go through these as well. Same idea though. So find the inverse function of f of x equals 4/9x. So we want to, instead of f of x, write y. And then switch the x's and the y's. And then now solve this for y. So the way you want to solve this for y is you need to get y by itself on one side. So to do that, you have to get y out of the denominator first. So you need to multiply both sides by y. So on the left side, you'll have y times x. On the right side, you have divided by y, multiplied by y, so those will cancel each other out. You're left with just 4/9. So now to get y by itself, you need to get rid of this x over here. So right now, we have y multiplied by x. So to get rid of that, we have to divide both sides by x. So those cancel. And then this 4 divided by 9 divided by x, you can rewrite that as just 4/9x. Those two denominators become the same. If you could also think about it as 4 divided by 9 and then multiplied by 1/x. And then you just multiply across. So you get 4 on the numerator, and then 9 times x becomes 9x on the bottom. Another way you can think about it. So this becomes our inverse function. So now let's look at this example. Here we have some rational exponents. So on the domain x is greater than 0. So we want to take f of x and replace it with a y. Switch our x's and y's. And then now we want to get y by itself. To do that, we have to get rid of this exponent over here. So we want to make it so we want to raise all of this, which means we'll have to raise all of this as well, to an exponent that will make our exponent just 1. So we want to raise it to, it'll have to be negative, and it'll have to be the reciprocal here. Because remember, when we raise an exponent to another exponent, we multiply them together. So I chose negative 3 halves because I know that negative 2/3 times negative 3 halves is 1. So what that gives me here on the right side is 3y to the first power. On the left side, I have now x to the negative 3 halves power. And then now to get y by itself, I just have to divide by this 3. So I have y equals x to the negative 3 halves over 3. Okay. Last example here on this slide. So same process. Now to get y by itself over here, we have root 3, which you could do this the same as we did this one up here. You just have to write it in exponential form, which root 3 is the same thing as raising something to the 1/3 power. So I can do the same thing. I can raise both sides to the 3rd power instead, because what that does, remember when you raise an exponent to another exponent, they multiply. So 1/3 times 3 I know is 1. So that simplifies this right side to just be 5y to the 1st power. Left side, x to the 3rd power. Then I can divide 5 on both sides. So then I have y equals x to the 3rd power over 5. So now I have y by itself. I can go ahead and use my inverse notation. So that is my answer for this one. And I did not box this one. Let me do that. All right. So we have one more type that I want to look at. Last example, graph the inverse of the provided graph on the accompanying axis. You must plot at least 5 points. So we're given this graph, this solid line, and we want to graph the inverse. So first thing we got to do is we got to come up with the equation for this. So that's going to be y equals, and then our slope is 1, 2, 3. Right, rise 3, run 1, and our y-intercept is 1. So that is our equation. Now we just want to come up with the inverse. So should be this, right? And then once we have that, we can start plotting our points. Now, tricky thing about this is we have a y-intercept of negative 1/3. So that's not one that we can plot because it's only letting us plot on grid lines here, no fraction plots. So let's see, what is one that we could do? I'm thinking we could plug in 4 for x. Let's see, let's make a little table. If we plug in 4 for x, then we get y equals, this becomes 4/3. And I did this because I want to get this 4/3 minus 1/3, which is 3/3, which equals 1. So that is one coordinate. We can plot 4, 1. And then from there, we can just keep plotting points using this 1, 3 slope. So do that. Rise 1, run 1, 2, 3. And then we keep going. Then down 1, left 1, 2, 3. Down 1, left 1, 2, 3. So should look like that. All right, that is my last example. If you have any questions, make sure you are asking for help during class. And have a good day.